Okay, now I'm back. Let's continue to work on this. So we were trying to improve space complexity by removing the result grid and only using an integer array instead. And one variable called left, which is just marking whatever that's to the left. And then we changed accordingly, but we got wrong answer. So let's step through the algorithm and see what's wrong. So that's the example. Let's see. Okay, left is 1, starting with 0, 0. So result array, we have one row of results. First one is 1. Okay, now we go to 0, 1. So I is 0, left is 1. So we're not going into this part, we are going to this. I is 0, j is not 1, and result 1 is 1, which is here. Now we go to I is 0, j is 2 for this cell. So left is still 1. So we are doing this part again. So we have 1, 1, 1 in the result array. Okay, now we go to I is 1, j is 0. So j is 0, but result 0 is 1, so we will not go in here. So we will go in here and result 0 will be 1, writing over the array above. Now we go to I is 1, j is 1. That will go here, so result 1 would be 0. Now I is 1, j is 2. That would be result 2 is the one above the last row, result 2, which is 1 plus left. Left should be 0, but right now left is still 1 because we did not update this left. Okay, so what is missing in this algorithm is the update of left. Okay, so this step will be counting above and left should now be updated to be this. To be used for the next so left J 0, so that left will be 0, left will be 1. Yes, okay, let's run this. Yes, okay, let's see. Yeah. Okay, So now we have managed to improve space complexity to only to be the size of n, because we are only using one row of one integer array, one row of size n. Okay, so that's good. Let's go back and see. So at least that part I've improved, but this solution still looks much cleaner. Let's see if I'm missing something really smart here. Okay, so for each row, if it's 1, which means if it's an obstacle, we will just have it to be 0, yes. Else, if it's bigger than 0. Okay, if j is bigger than 0, which means not 0, okay, then we do that plus the 1 to the left. Oh, so they don't even need to use the left integer that I'm using. Okay, so we do not need that. Let's see. So we do not need this. We should get rid of this. So why wouldn't we need this? if it's an obstacle, we have 0. Else if I just be the 1 plus the one to the left. Okay, so the new one will be, so this would be the one above, and this is the one to the left. Not completely getting this. Okay, so what we are doing now is so we have one array, index 0 initiated to be 1. Now we go to the next, to the right. We just do plus the left. Okay, so that becomes 1, that becomes 1. And what if we had an obstacle here? That would be 0. Okay, and the next one would be 0 as well. Okay, next row. Next row, if it's an obstacle, it's 0. Otherwise, it would be that. Oh wait, if it is the first row, j is 0. In that case, nothing happens. So if j is 0, if I is 1, j is 0, this is not an obstacle, so that's not 0, but nothing happens because we're only doing something when it's not the first row. Okay. And now here, in this case, there's an obstacle, so we are not doing anything. This will just be 0. And the next one, I is 1, j is 2. So we are adding this with this. Oh no, we are adding this and this because there was an obstacle, so that became 0. Okay. Okay, because this part will always be the one that we just calculated to the left. So that will be the same as left. And this part will be the one above from the last row. So we're always adding the one above and the one to the left, like I was doing before. Just now that we don't have to have an extra variable for left. Okay. Okay, that's smart. And it also handled these special cases. First row. Okay, so that just very smoothly handled all the special cases when there were obstacles and we need to set it to 0. So these cases. So we have, so that's all handled. And this is this part. And this is also handled in here and here as well. Okay, so that's all good. Very smart indeed. What if we have that result 0? Okay, so that worked as well. Very clean and smart indeed, the top solution. So that was my first solution. So first solution was using m times n space. Then we optimized to use just int array, so only n space. And we have a cleaner version to write the same algorithm. So very nice indeed. Dynamic programming. Let's look at one more. So this is so they are creating one size bigger and then starting from 1. Okay, so this is actually the same idea then. Okay, let's look at one more and then that's it. M and N, also one extra. Oh wait, but this looks like the same solution as the last one. If it's not an obstacle, then we do this. Oh, okay. It's using a flag. Okay, it's getting too late, so I'm feeling really sleepy, so I can't read through that right now. Even though I should. But let's see. Well, essentially, since the default values are 0, so we don't actually need to specifically do this step. If we don't do anything, it will be 0. So we just need to make sure to get the right condition when it needs to be 1 and when it needs to update. So from that angle, we should also be able to refactor a bit and get rid of this part. So when it's not an obstacle. Okay, now I also see why they were doing m+1 and n+1, because then they don't need to deal with the problem of I-1 and j-1 being out of bounds, so they could just start directly at index 1 on 1, and since the default values are 0, so that would just work perfectly because they're just adding a 0. Then they don't need to deal with Okay, I think I have all the ideas now, so I'm good with this problem for now, and it's also late, so I have to do some other stuff. So that's it for this one. Did I miss anything? Oh, okay, let's see. Okay, dynamic programming, matrix array, similar questions. Oh, there is a unique paths theory. That's hard. Okay, we are skipping all the hard problems for now, at least. Alright, good night.